Today we're going to be talking about 5G, understanding 5G completely, and making sure that you have the correct wording and terminology to have a discussion regarding with your peers of what 5G does. So we appreciate you joining our series today. We'll be going through and taking a look at some key slides where we learn about 5G being present in our current environment and a technology to be moving forward with. We're going to start with 5G wireless, understanding the basics. Understanding the basics of 5G wireless networks. Wireless networking has improved significantly over the last several years. As enterprises accommodate increasing numbers of mobile devices, accessing their networks are important. The telecommunication industry hopes fifth-generation wireless technology will represent an even greater leap forward in network performance, enabling enterprises to tap into a broad range of new appliances and services. What is 5G? Building on fourth-generation wireless, long-term evolution, that's what LTE stands for, long-term evolution services, 5G wireless is expected to carry great amounts of data over much faster network speeds. With a sub-millisecond latency, at peaks, 4G performance cellular networks can transfer data at the speeds of about 1 gigabit per second. With 5G, wireless networks, however, performance will increase drastically, and data will be moving at faster speeds, as fast as 10 gigabits, equivalent to a wireline speed in your current network. So let's talk about this. The reduction in network response times, meanwhile, is a significant enhancement. As a result, 5G architecture holds potentials for new technologies such as remote online surgery, the embrace machine learning and artificial intelligence, virtual and augmented reality, and the Internet of Things. As the commercial deployment of 5G wireless networks get closer, mobile operators are preparing to roll out two main types of new 5G services. The first is a fixed wireless broadband, which will be available in some of the major metropolitan areas at the end of this year. And the second is the mobile 5G cellular, which is expected to be available at the end of 2020. Analysts expect operators will have full 5G wireless deployment in place by the year 2025. There are two types of 5G service networks. The fixed 5G wireless broadband. This service is designed to deliver fast, last-mile internet connectivity to a business or residence using radio signals rather than the wired connection directly to your premise. So most build-outs today, if you want to install fiber or some type of line directly into your business, includes the over-air installation of cabling into your building or the digging of trenches underground to bring your fiber directly to the building itself. A lot of buildings in today's market looking to enhance to 5G speeds have the process issue of having to deal with that extra mile. Coming from pole to pole is easy, but from that pole to the building itself is the biggest obstacle that telecommunication companies face today. Having the ability to have a tower that has a wireless shot that shoots directly from that tower bridge over to your business is what we're talking about in segment number 1 here, which is the fixed wireless broadband. To provide such wireless broadband, carriers deploy a 5G radio on a small cell site, such as a streetlight or telephone pole, to deliver the signal to the wireless modem installed inside the building or residence. This replaces that need for that fiber cable or other hardwired lines to be connected directly to a building. The third-generation partnership, 3GPP, that was originally created in December of 2017, completed the standards for the 5G radios needed for a fixed broadband wireless solution. The next thing that we have here is 5G mobile service. Operators also plan to offer 5G mobile cellular service, which will be enabled by the next development of the evolved packet core. Very important is the way the packets are shaped. So they have a complete technology called evolved packet core, LTE advanced wireless connectivity. Cellular 5G mobile services can't be rolled out until 3GPP has completed its 5G mobile core standards. Analysts expect mobile operators to begin deploying 5G mobile services towards the end of 2020. Some customers are already being enabled for that service, and then having the standard enterprises of phones, including the 5G cellular connectivity that will be able to enhance those services. So let's explain here just a little bit about the difference between a 4G connection at ultimate speed versus a 5G connection. So let's take, for instance, a standard high-definition data movie transfer. Not that any of us are downloading HD movies from the internet for personal viewing, but if you were, most of the size of these are anywhere between 7 gigabytes of data all the way up to a larger data set. But we're going to start with our core as being that 7 gigabyte for an HD 720 1080 uncompressed video file to download. Currently with 4G, it would take you equivalent to about 56 seconds, so just right at that minute point to download that file. With optimization of 5G, you're looking at it taking less than 4 to 5 seconds to download that file, which previously took a minute. Really, the key part here is the compression algorithm that is being used on the packet header and the packet endpoint of how it's sending this data. This data is being sent very much like what is considered an SDWAN solution, where the encryption packet at the header of your information has all the information of the packet it's sending. Distributed it into an area, all you have to do then is have your return packet and your last end packet IP address be sent to enable that packet to be distributed across the system. So essentially what that does is it's compressing everything. It says stop and go, and the stop and go process, instead of doing it for every packet, it does it for one large packet. This solution has been in place with SD-WAN solutions for quite a long time, and using this in the 5G technology makes complete sense. Who benefits from 5G? Let's talk about this. The 5G infrastructure market is poised to grow significantly from a $2.9 billion industry in 2020, currently right now. Even with the COVID-19 pandemic that has hit, the target numbers of $2.9 billion are still in place. But if we look ahead into 2025, 2026, this market will be in a share of anywhere between 30 to 34 billion, according to Markets and Markets' latest analysis. Fueled by demand for mobile data services, the growth of industrial automation has increased the use of software and communications networks. 5G is being used currently right now in a lot of the medical industries for telemedical information back and forth between countries to share technology regarding the COVID-19 pandemic that we're currently having. Having this ability to send strands of data and send live video conferencing back and forth without any delay has been a key significance during this pandemic. 5G is currently working at this time and has been very successful. For industries that require a low latency and high throughput, as we were talking about, like the healthcare, financial services, energy, and other field service organizations. So think about anybody out in the field that has remote locations, a remote workforce. This also works well for the Comcast networks, the wired large cable companies that have a remote distance workforce. Having 5G network is expected to significantly increase impact. The businesses now can have communication requirements and manufacturing processes available at all remote locations. Working from home is an added benefit of this, considering you can have development engineers viewing live code on a 5G radio broadcasting in the middle of the hills of Oregon or Washington without any delay on the actual ability to upload course files. Service providers are helping drive 5G development. According to TBR, more than 85% of the funds earmarked for 5G development come from communication service providers in 4 countries. The United States, China, Japan, and South Korea are these leaders. Operators in the countries have made 5G a priority to focus. In the United States, Verizon and AT&T have started 5G trials and have 5G clients currently available. T-Mobile is also announcing large 5G services in major metropolitan areas, as you can see in current ads that they are speccing. Again, the 5G business development has not been completely developed to a maturity level that enables all of your wireless devices to enable the services from business to business. The role of SDN and 5G technology in the WAN. Can it scale? The big part about 5G is the software-defined networking. SDN is one of two major pillars of the network transformation that has emerged. When SDN was introduced, many expected it to sweep traditional routing and physical routers out of the network, but it has not. And while SDN has earned a place in the data center, SDN in the WAN is still rare. This will change with the 5G deployment of wireless networks, but it's a little bit complicated, so let's talk a little bit more about this. Explicit control of forwarding via OpenFloor, the Open Network Foundation, ONF version of SDN, is the model most people think of when they think of an SDN solution. In the data center, particularly in cloud data centers, where virtual LANs have been deployed to build multi-tenant services and applications. This version of SDN has been widely adopted, and it provides a model that works, but it does not scale successfully. Scalability is the biggest challenge with SDN in the WAN environment. If you ask whether the internet can build on SDN, almost every network operator would be skeptical. If you accept that some IP networks are too big for the ONF modeled SDN to work, then how are big networks going to use this? Well, the good news for SDN and 5G technology and other metro-focused changes in the networking build of how the bridge for SDN and the data center communicates. 5G has specific features that encourage SDN deployment, including network slicing. The combination of 5G networks, functions, visualization, edge hosting, and content delivery and streaming makes considerable deployments into the metro networks. New or greenfield deployment, particularly well in a manageable metro-sized parcels, is the ideal place to introduce new technology, which is opening up an SDN in WAN. Mobile networks have been a combination of mobility management and content delivery features. Emerging with the 5G network adds the network visualization and network slicing addresses the need for multi-tenant mobile and the additional features of allowing adoption for virtualization. It opens two avenues to SDN in the 5G metro, using SDN for data centers, interconnected DCI, and for mobility and content management. Both 5G and mobile content are credibly edge hosting drivers as services feature and content cache ports need to be close so that they're using the service. Edge hosting, which is a huge thing that we have talked about in our TLG groups, and into our looking for the upcoming future of technology, means that the edge hosting enables you to have fat pipes that connect data centers in the SDN connection, but the wireless from endpoint to endpoint can be virtual with high packet involvement. SDN will continue to be developed in the 5G technology, and essentially 5G and the layers itself between company and company are going to utilize these SD compressions to each of their advantages. No 5G network is the same. When people say we have 5G, we have 5G, and we have 5G, that's great. But understanding how AT&T versus T-Mobile versus Verizon versus a 5G standard adoption is important because each vendor in each area will be using their own deployment methods. So let's talk about Verizon's 5G rollout could change significantly. Verizon has chosen to temporarily forgo the standards and launch a proprietary 5G internet services to homes in 4 U.S. cities. The rest of the market was the first to start the generation of billions of dollars spent on the 5G network. 5G network is promising service providers a baseline speed of 300 megabits per second, which is significantly higher than Verizon's current fiber optic service from Fios. Customers covered in the Verizon 5G rollout could experience speeds close to 1 gigabit. It's also favorable locations relative to the Verizon's 5G small cell sites that broadcast the wireless signal to the home. Verizon plans to change the wireless subscription to a $50 a month for 5G service and non-wireless subscribers for up to $70 a month. Verizon won't charge the first few months of the service for 5Gs and routers as they install them into your home. Because 5G is a fixed wireless technology, Verizon can compete against cable companies and rivals AT&T without having to bring a cable connection to the home or apartment buildings. If you have broadband delivered to your homes over the air, then it becomes a lot faster for a customer to provision the service. So if you already have an over-the-air activation, Verizon is currently looking at this customer base. All right, 5G quiz time. Hopefully we're all paying attention, so we are ready to answer this. What does 5G stand for? Does it stand for A, 5 gigabytes of data, B, fifth gateway, C, 5 gigabytes, or D, fifth generation wireless? Take your time to answer that. And the correct answer, of course, is D, fifth generation wireless. It's a terminology in the industry that just means that there is a whole new technology that is coming on out. Let's continue on to question number 2. 5G will offer latency of 1 millisecond or lower. What does latency refer to? A, here we have a time that it takes to reboot a connection. B, the length of time devices will automatically connect to the network. C, the delay between an input and desired outcome. Or D, the speed of detecting a disruption to the network. And the correct answer is C, the delay between an input and desired outcome. Question 3, to accommodate faster data transmission speeds, 5G has greater bandwidth. What other term is synonymous with bandwidth? We got A, capacity, B, speed, C, connection, or D, strength. Question number 3's answer is, of course, A, the capacity of having a data transmit at speeds and allows us to have the ability for packet transfers to greatly be increased. Okay, question number 4. To generate high speeds, 5G utilizes the band of spectrum between 30 gigahertz and 300 gigahertz. What is this band spectrum called? Is this A, millimeter wave, B, lower frequency spectrum, C, real-time spectrum, or D, radio frequency band? And the answer for question number 4, of course, is B, lower frequency spectrum. The 30 gigahertz and 300 gigahertz bandwidth is considered a low frequency spectrum. Question 5, network slicing is a network management feature that 5G will allow. What does this mean for users? A, the ability to set up multiple connection points to one 5G network. B, the ability to create multi-virtual networks within a single 5G network. The ability to designate multiple passwords for one 5G network, and that's C. Or D, the ability to utilize connections from either nearby network. And question number 5's answer is A, the ability to set up multiple connection points to one 5G network. And that gets us through our questions. We had 5 questions to remember regarding our 5G technologies. So 5G is going to be around for quite a long time. It's an exciting area of development. It is not a specific technology name. It is not a branding of a certain compliance of how people need to send or receive data. But what 5G allows is a spectrum range from that 30 megahertz to 300 megahertz availability for anybody to use to transmit high-speed data using some of the technologies that we have currently in SDWAN capabilities of packet control.